Hey friends, this is a video lesson for our Light Waves lesson 2.1. Just a reminder, this video is meant to guide you through each activity. Be sure to pause the video throughout so that you can complete the activities as they are shown to you. So this lesson has 4 parts in Amplify. As you can see here, we are doing a sim, we're reading an article, doing some warm-up questions in Amplify, we're skipping a part, so we should get through this pretty quickly. All right, so part 1 in Amplify. You should have completed a response earlier in this unit, and it should show up right here for you. If it does not, do the best you can, because you can still figure out whether or not you agree with the original statement. And the original statement would be all light is the same, whether it comes from the sun, a light bulb, or anywhere else. So even if you don't have your statement here, you can think back to our last activity where we actually got to see how different kinds of light react, or different materials react differently to different kinds of light. There it is. Finally got it out. So here you're going to agree, disagree, not sure. It is up to you. Right now, though, we should be getting the idea now that this is a false claim. But go ahead and answer, and then which piece or pieces of evidence support your ideas about the statement. So go ahead and complete that activity. Push the hand in button. Pause the video if you need to. And then we are going to move on to part 2, which is this article. So we're going to read this article. There are instructions for you to annotate. We're just going to skip that. I do want you to do a close read and pay attention to those vocabulary words. But you're just going to click on this little button here. Oh, come on. It'll get there eventually, friends. So go ahead, and we're going to do a deep dive into reading this article. Go ahead and pause the video. I do want to point out that you can request to have the video read aloud by pushing this little speaker button in the upper left corner. Okay, so hopefully you've paused and done your own reading. Let's go ahead and review some of the key points of this article together. So the article dives in as a reminder of what photosynthesis is, something that we should have all learned about by now, that process by which plants take in energy from the sun and carbon dioxide from the atmosphere and use that to create energy. As we go in, we learned that plants absorb all sorts of different kinds of light from the sun, but only certain wavelengths or portions of that different kinds of light are important for the sun. Most notably, infrared, little ultraviolet, and the visible spectrum is what plants need. While some of these other ones, like gamma rays and X-rays, and even ultraviolet, to some degree, can damage the plants, but that won't happen if we're using light bulbs, which is kind of cool. And they do that down in Antarctica, in fact, where because there's no sunlight down there, they have to rely on bulbs to grow. And we can see here with this little table, we've got quite the breakdown of why this actually might be more beneficial. We might actually get healthier plants in the long run. Because you can see with the sunlight, they do have to absorb these gamma rays, X-rays, ultraviolet, all of these different, where it's just visible in infrared, which will not damage the plant, but also give the plant the necessary energy and type of light that it needs in order to grow. Okay, so let's go ahead and back out of here. And we are skipping part 3 and we're going straight to part 4. So for part 4, friends, we're doing another simulation. Let's see here. Where's my... Sorry, friends. I just needed to scan ahead and I somehow lost my pause button, so I couldn't pause. So we're going to use our light waves simulation. And what we're really going to do is we're going to compare different light sources on different materials, something that we did a little bit of in our last lesson. We're going to do a little bit more of it to really support our thinking and get us to understand that there's different kinds of light and that those different kinds of light cause different reactions to different materials. Okay, so we're going to open up our light waves. We're going to keep the sun as our source, turn it on. We're going to inspect the light beam. We're going to look at the different types, and then we're going to do the same thing with the light bulb. Then we're going to answer these questions. What type of light that the sun emits, but the bulb does not? And then what type of light that both the sun and the bulb emit? So this should be a pretty easy sim to run. Let's go ahead and do that real quick. Turn it on. Boom. Yeah, I want to show the energy. Ooh, look at that energy. And then we're going to inspect it. So now we can kind of see all the different wavelengths of light: gamma ray, X-ray, ultraviolet, visible, infrared, microwave, and radio. Those are all the different kinds. Okay, so now we're going to do the same thing, but with the light bulb. And we're going to see infrared and then visible light. So we don't see gamma ray, X-ray. We don't see microwave or radio waves. Oh, we also don't see ultraviolet. So now that we know those things, we can go and answer these questions. So which type of light that the sun emits but the bulb does not? Well, ding, 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 right? So it emits all of those kinds and the other one does not. Am I correct? Yeah, because the other one just does visible and infrared. Did I get this backwards? Hold on. Brain's broken. Visible and infrared. But all these other kinds. Okay. So what is a type of light that both the sun and, visible and ultraviolet? Okay. Does every light source emit only one type of light? I'm not going to give you the answer to this, but I do want you to get the right answer. Hopefully we know it by now. All right, friends, select your answer, push the hand in button, and then you are done. Nice job.